All right, let's talk about one of the classic crossroads every single developer hits: Node.js versus Spring Boot. But you know what? We're not just going to run down a boring feature list. No, we're going to get into the heart of it. This is really a choice between two totally different philosophies for building the backend, a battle between lightning-fast agility and rock-solid structured power. So picture this. You're spinning up a brand new service. This is the big question, right? What are you going to build it on? Are you aiming for something that can iterate super fast and handle a crazy amount of connections? Or do you need something with ironclad stability, something that can handle heavy-duty number crunching? The choice you make, right here at the very beginning, sets the stage for everything that comes after. So let's start by unpacking the whole philosophy behind Node.js. Okay, first up, Node.js. Its entire reason for being, its whole philosophy, boils down to this one absolutely game-changing idea: asynchronous, non-blocking I/O. And trust me, this approach completely flips the script on how a traditional server handles requests. So what is Node.js when you get right down to it? Well, at its core, it's an asynchronous, event-driven framework. And look, those two phrases, asynchronous and non-blocking I/O, they are not just buzzwords you throw around in a meeting. They are the fundamental principles that give Node its incredible efficiency. So, how in the world does it actually do this? Well, its secret weapon is something called the single-threaded event loop. And I know exactly what you're thinking, because I thought it too. Wait, a single thread? That sounds backwards. How can one thread possibly be better than a whole bunch of them? The magic, my friends, is all in how it uses that one thread. Let's actually walk a request through this system. Okay, so a client request comes in. Let's say it needs to fetch some data from a database. Now, instead of just sitting there and waiting, the event loop says, hey, this is going to be slow, and it offloads that I/O task to a worker pool. And here's the genius part. The event loop is now totally free to grab the next request in line. It doesn't wait for a second. Later, when that database operation finally finishes, a little message, a callback, gets put in a queue. The event loop, on its next pass, sees it, processes it, and sends the response back. This is how a single thread can juggle thousands of connections at once. But this also shows you its biggest weakness. If you give it a heavy CPU-bound task, you block that entire loop, and everything, and I mean everything, just grinds to a halt. So, knowing all that, where does this philosophy just totally crush it? Well, its sweet spot is any application that does a ton of waiting around. Think about real-time chat apps waiting for the next message, or APIs that are just constantly pinging a database for data. If your application's life is mostly I/O-bound, waiting on the network, waiting on the file system, Node.js is an absolutely fantastic choice. Okay, now let's completely switch gears and talk about a totally different way of thinking. Enter Spring Boot. This isn't about that single-threaded agility. Oh no, this is all about structure, robustness, and the raw power you get from a mature, truly battle-tested ecosystem that was built from the ground up for massive enterprise-level challenges. And the official definition here really tells you a lot. First, it's Java-based. That one word immediately brings things like performance and stability to mind. And then you see production grade and standalone. Those words point right to its main goal: helping you build complex, serious applications without all the painful manual setup, the boilerplate code that the original Spring framework was famous for. And what's holding all this up? Underneath everything is the Java Virtual Machine, the JVM. This is the absolute foundation of Spring Boot's power. The JVM brings true multi-threading to the party. That means it can spin up a dedicated thread for each request, which is just perfect for those heavy CPU-intensive calculations. It's a genuine performance powerhouse. But here's the thing. You're not just getting the JVM. You're inheriting the entire massive Java ecosystem. That means you get strong typing, which catches whole categories of bugs when you compile your code, not when it's running in front of your customers. It means you have access to a huge universe of mature libraries for practically anything you can imagine, plus enterprise-grade security and some really smart auto-configuration that does all the boring setup work for you. All this structure and power makes Spring Boot the absolute go-to for big, complicated systems. We're talking large-scale enterprise apps with super intricate business roles, sophisticated microservice architectures, or heavy-duty data processing jobs. Basically, when reliability and complexity are your biggest worries, Spring Boot is right in its element. Okay, so we've got the philosophies down. We understand the different mindsets. Now it's time for the main event. Let's put these two titans head to head and see how their core ideas really stack up in the real world. At the very heart of this is the language itself. With Node.js, you've got JavaScript. It's dynamically typed, it's interpreted, and that often means you can develop faster and write less code. It's great for getting things done quickly. Java, on the other hand, is statically typed and compiled. Yeah, it can feel a little more verbose, a little more ceremony, but that static typing is like a safety net. It catches a ton of errors before you even run the code, which can be an absolute lifesaver on large teams and complex projects. And this table right here, this really crystallizes the trade-offs. Just look at that first line, the concurrency model. That's the whole ballgame. Node's single thread is a genius at I/O efficiency, while Spring Boot's multi-threading is all about raw computational horsepower. And that directly affects what they're good at. And check out the learning curve. JavaScript makes Node really accessible, which is a huge win for getting started. But the steeper curve of Java and the whole Spring ecosystem, well, that initial investment can pay off big time in the long-term stability and maintenance of a huge application. So after all of that, how do you actually make a choice? The biggest takeaway here, honestly, is that there is no single best framework. There just isn't. It's all about that classic engineering mantra, picking the right tool and, in this case, the right philosophy for the specific job you have in front of you. So it really all comes down to this, doesn't it? After breaking down the philosophies, the architectures, the pros and cons, what's the final verdict? Which one should you and your team bet on for that next big, critical project? And the real answer, maybe not a surprise to experienced engineers, is it depends. It completely depends on your context. The most important questions you can ask aren't really about the tech itself. They're about your project and your team. What do you actually need to build? And what does your team already know how to do well? That's where you're going to find the right answer. So let's make it super practical. Here's your cheat sheet. You should probably choose Node.js if you're building real-time apps like a chat service, an API that is doing a ton of I/O, or any project where just getting to market fast is the most important thing. On the flip side, you're going to want to choose Spring Boot for those big enterprise systems, complex microservice setups, or any project where you absolutely need strong typing and raw, unadulterated performance. And that brings us to one last really big question to chew on. As our world keeps changing with serverless, with containers, with all these new languages popping up, which of these two philosophies is actually better suited for what's coming next? Is it the lightweight, highly concurrent, get-it-done-fast model of Node.js? Or is it the structured, powerful, all-inclusive ecosystem of Spring Boot? There is no easy answer here, but it's the question that's going to define the next decade of how we build things on the back end.